Why can't we create anti-gravity yet? Have you ever wondered why we can't just flip a switch and turn off gravity? It sounds like something out of a science fiction movie, but the truth is much more complex. Gravity is a fundamental force that is deeply woven into the fabric of our universe. And like electricity or magnetism, gravity cannot simply be turned off or countered. It is understood through Albert Einstein's theory of general relativity, which describes gravity as the curvature of spacetime caused by mass and energy. This makes the idea of creating anti-gravity extremely challenging with our current understanding of physics. Throughout history, there have been many quirky experiments aimed at creating anti-gravity. One notable figure is Thomas Townsend Brown, who worked in the 1920s. He experimented with high-voltage devices known as gravitators or electrogravitics. Brown claimed that these devices could produce a force that counteracted gravity. He used asymmetrical capacitors and high voltages, reporting strange effects like changes in weight depending on orientation. However, later investigations revealed that these effects were likely due to ion wind, which is the movement of charged particles in air, rather than true anti-gravity. When tested in vacuum conditions, where ion wind cannot occur, these devices did not produce any thrust, indicating no genuine anti-gravity effect. In more recent years, scientists have turned their attention to superconductors and quantum effects. For instance, physicist Ning and her team in the 1990s theorized that certain superconducting materials might create a repulsive gravitational effect under specific conditions. They observed unusual weight fluctuations in objects suspended above spinning superconductors, hinting at a possible tiny anti-gravity-like effect. However, these results remain controversial and have not been reproducible on a scale that would lead to practical anti-gravity devices. No object has been made to levitate or float freely in these experiments. The effects were subtle and not fully understood. One of the main reasons we struggle with anti-gravity is that gravity is incredibly weak compared to other forces. It acts universally on mass and energy. Unlike electromagnetic forces that can be shielded or manipulated, there is no known material or technology that can shield or negate gravity. Theoretical ideas like gravity shields or exotic matter with negative mass remain speculative and have not been demonstrated experimentally. Various government and military research projects have explored anti-gravity concepts for decades, but no verified technology has emerged that can break gravity's hold. The realm of weird science is filled with odd devices and mysterious claims related to anti-gravity. The history includes high-voltage tubes that seem to change weight and spinning superconductors with unexplained anomalies. Yet, these experiments often lead to quirky results that do not hold up under rigorous testing or are explained by more ordinary physical effects. The allure of anti-gravity continues to inspire unconventional experiments and fringe theories, but the core issue remains. Gravity is a fundamental aspect of spacetime itself, not a force that can be easily reversed or canceled by our current scientific methods. So, why can't we create anti-gravity yet? The answer lies in the fundamental nature of gravity, the misunderstood phenomena behind experimental claims, and the lack of proven materials or devices to counteract this force. Despite decades of research and strange experiments, practical anti-gravity technology remains an elusive dream.